Okay, while you're cogitating on how you might go about solving a game like the Clash of Wills without coordination, let's have Marisha read the first problem I asked you to aid your reflection on this fascinating game.
Explain why, if two players coordinated their weekend by flipping a fair coin, it would make sense to assign the value 3 seconds to each of them.
Okay, so now we're going to assume that before they lost communication, they opted to simply flip a coin in order to coordinate their strategies. Not the case that they both would independently flip a coin, but this is while communication was still going on. They were going to sit there, engage in a coin flip, and heads, they would go skiing, say, tails, they would go to the festival. Okay? Now the reason why coordination of this sort can be important is because coordination of this sort rules out the two disadvantaged outcomes. If they're going to flip a coin and if it comes up heads, they're both going to go to the skiing. If it comes up tails, they're both going to go to the festival. Then we can rule out those two outcomes. They're not going to happen with this coordinated coin flip. So now from row, for example, we can calculate row's expected value of the coin flip. Well, that's going to be 1/2 of the chance that it winds up heads times the payoff if it winds up heads, plus the probability that it winds up tails times the payoff for row if it winds up tails, and that's going to equal 1 plus 1/2 equal 3/2. And you can see exactly for column or for Baker in the game we're looking at exactly the same. If it comes up heads, well, that's going to then be the payoff of 1. And if it comes up tails for column or for Baker, that's going to be the payoff of 2. And again, this sums to 3/2. So here's a way in which they can increase the expected value of this game. Okay? Notice if they both would just sit there and flip coins on their own. They would have a 1/4 chance of getting at that point if both flipped a head independently, a 1/4 chance of hitting that point if both flipped a head, if row flipped tails and column or Baker flipped heads, 1/4 of getting on this point if column flipped tails and row flipped heads, and 1/4 of getting on this point. And if you calculate out those values, you will see that by them independently flipping coins, they'll wind up with a probability of, with an expected value for row of 2 times 1/4. That is that's 2 times 1/4. That's 1/2. Minus 1 times 1/4. That's minus 1/4. 0 times 1/4, that's 0, and 1 times 1/4, and you'll see that this winds up with a payoff of just independently flipping coins of 1/2 for row, and if you do the same calculation for column, of 1/2 for column. If they can somehow coordinate that coin flip, where both are acting on the same coin flip, their expected value of this game in their own case rises from 1/2 to 3/2. Such is the value of coordination. If they could coordinate their strategy and both stick to the coordinated strategy, they'll have an expected payoff of 3/2 rather than an expected payoff of 1/2 if they both played that coin flip strategy on their own.